Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 172. Page 172, and today is our lesson number 155. Problem number 141 is what we are about to solve. The problem number 141 has a concept, an accounting concept, something known as a rule of 70. Now in some textbook, it is referred to as, it is also referred to as rule of 72. And if you use 72 instead of 70, then the answer becomes more precise than 70, but it's easier to divide with 70, so most textbooks simply refer to it as the rule of 70. Now this is what the rule of 70 says. The rule of 70 says, and this only applies when you're talking about compounding going on, when the object in question is compounding. Okay. Now notice how vague I am, now how generic I am in my speech. There is a reason for it. We'll come to that in a second. It does not deal only with money. It does not deal only with investment. It's a very, very broad concept. This is what it says. It says, number of periods it takes for something to double in size approximately equals to 70 divided by the rate of growth per period. 70 divided by the rate of growth per period. Let's start with something simpler, something having to do with money. For example, if I put, if we invest $1,000 at 7%, well, let's start with something simpler. If we invest $1,000 at 10%, compound it annually, this is what it is, it's compounding. Compound it annually. Of course, in theory, what we're talking about is the constant compounding every fraction, every fraction of a second. But let's not make it too complicated. Compound it annually. If that were the case, then one may leap to conclusion that, well, if it pays you 10% interest, and if I leave the money in the account, it will take 10 years for it to double in size. The answer is no. It will not take 10 years for it to double in value, because of the fact that it's compounding. We're not withdrawing the money. So if you don't withdraw the money at the end of first year, if it pays you 10%, which means at the end of first year, they pay you $1,000 in interest. We're not withdrawing that interest. So the next year, year number 2, begins with the balance of $11,000. And now we get 10% on $11,000. Which means at the end of second year, our interest is not $1,000, it is $1,100. We're not withdrawing that again. Which means we start our third year with not $10,000 of our original money, but $10,000 plus $1,000 that we earned the first year, plus $1,100 that we earned the second year. It looks like $12,100 if my arithmetic is correct. Anyway, the point here is that it keeps growing, and it does not take 10 years because of the fact that we are not withdrawing the money. It does not take 10 years. The question is, how long does it take for it to double in size? Well, of course, you can do the exact precise calculation and figure it out, but the quick approximation is that, since it is 70 divided by rate of growth, and the rate of growth here is 10%, 70 divided by 10 is just 7 years. So it will double in size in approximately 7 years, not 10 years. Now, on the other hand, if it pays you 7% interest, then the amount will double in size in 10 years. 70 divided by 7. 70 divided by 7. Now let's talk about something more generic so that you can understand the concept. Now here's the thing. So we have I think it's called, I don't know what it's called, but it's a small round plate that the scientists use in the laboratory where they have the culture of a bacteria. It starts with a P. And the only one that comes to my mind right now is pastry, and I know it's not pastry obviously because I'm hungry. It starts with P. I don't know what the word is. But anyway, it's a dish, it's a round shaped dish, not a pastry. Okay, that's yummy, that's something different. And it's a round cultural thing, not cultural thing, it's a culture of bacteria, and it's there, and it's growing. let's pretend that it's growing at 7% per minute. It is growing 7% per minute. You see, number of years it takes for something to double in size. Oh, it doesn't say number of years. You see, I caught myself. It says number of periods. It's a very generic, very broad concept. It does not have to be year. It could be weeks. It could be months. It could be days. It could be seconds. Number of periods it takes for something to double in size equals 70 divided by the rate of growth per period, whatever that period happens to be. Here it is 7% per minute. That's your period. Our period here is a minute. So if it's growing, if that bacteria is growing at 7% per minute, how long will it take for that bacteria to double in size? Well, the answer is 10 minutes. 70 divided by 7. That's all. Let's do one more example, shall we? We have a population of a country. We are told that the population is growing at 1% per year. If the population is growing at 1% per year of a country, how long does it take for the country's population to double in size? Now in your haste, you might come to a conclusion that if it's growing 1% a year, it will double in size in 100 years. No, it will not double in size in 100 years because again the compounding is going on. The babies that are being born few years down the road, they will make babies themselves. Do you understand? So if the population is growing at 1% a year, it doesn't take 100 years for it to double in size. It takes approximately 70 years. You see, 70 divided by the rate of growth. The rate of growth here is 1. So 70 divided by 1 is 70. So it will take approximately 70 years for it to double in size. If it were growing, if the population was growing at 2% a year, if the population is growing at 2% a year, it will double in size. It will double in size in approximately 35 years. You must say approximately because this is not a precise figure, obviously, because for the precise calculation we'll have to do the logarithm and so forth, and we can do it very quickly. It's not actually that complicated. But if you want a quick and dirty answer, it's just 70 divided by 2, which is 35. 2%, by the way, I'm digressing here, which has nothing to do with GMAT at all. This is just a general knowledge. 2% is, by the way, is very close to what is known as the natural replacement value. The natural replacement rate is 2.1%. If the population is growing at 2.1%, it stabilizes. It does not no longer grows because at that point the birth rate and the mortality rate, they cancel each other out, assuming there is no immigration going on. So if it's just the rate of growth of natural growth of the population, 2.1% is what is known as the replacement rate. That's where the number of people who are being born equals out the number of people kicking the buckets every year, as we put it so sentimentally. Anyway, so that's what's going on here. In this example, the question is, we are investing $5,000. We are investing $5,000 at 8% for 18 years. And the question is, what's going to happen to our $5,000 if it's invested at 8% for 18 years? Let's find out. 70 divided by 8, that's your 70 divided by rate of growth, is approximately 9. It's approximately 9. Why? Because 8 times 9 is 72. In other words, actually, if you were to use rule of 72, they talk about the rule of 70 here. As I said, some textbooks talk about 72. Had it been 72, it would have been exactly 9 years, but anyway. So what this tells us is that 70 divided by 8 is approximately 9. What this tells us is that our money will double in 9 years. In our 9 years time, our $5,000 will become $10,000. But we're not investing for 9 years, we're investing for 18 years. So we start out at the year 0 at $1. At the end of 9 years, it becomes $2. At the end of 18 years, which is another 9 years, 9 to 18 is another 9 years, and our $2 becomes $4. In other words, our money would quadruple. And that implies that our money will quadruple in 18 years. In 18 years time. In 18 years time. The question was, what would happen to our $5,000? Well, the answer is very straightforward. Our $5,000 will become $20,000. And the answer is A. Our $5,000 will become $20,000. Because at the end of 9 years it will double in size. At the end of other 9 years, the double amount will double again. And doubling of the double amount will become quadruple. That's all. So that is what is known as the rule of 70. I'll see you tomorrow, okay? Bye now.